In this lab, we're going to be demonstrating equilibrium in terms of Le Chatelier's principle. And Le Chatelier's principle, of course, is the idea that when a system at equilibrium is stressed, that stress will be negated by a shift in the equilibrium, either favoring the products or the reactants. Or another way of saying that is the forward reaction rate becomes more dominant, or the reverse reaction rate becomes more dominant. Keeping in mind that this lab is based out of your module, take a look at the equilibrium equation for the cobalt chloride complex, including water and chloride ions. And what we'll do today is we'll demonstrate the stresses and the shifts to the equilibrium. And in order to do that, we're going to use our cobalt complex here, which is an equilibrium system. Because if we do take a look at the reaction, we'll see that the reactants and the products are different colors. We have pink and blue, and when put together, the equilibrium is a purple color. Now, the actual description of the color is entirely up to you, as long as we understand the purple here is a blend of both reactants and products, the blue and the pink states. So this here is called our control. Now, this is not a controlled variable, this is a control. A control is going to be something that is unchanged. We are not actually going to add any variables to this system, and it's unchanged so that we can compare any of our tests to the original sample. So this is going to be our color comparison when we stress the system. Our first stress that we will apply here is increasing temperature. So we take this beaker of water right off the hot plate, and we're going to take a little bit of our sample here, and we're going to add it to the hot water, and we're going to look for any changes. Now, temperature changes may take some time. However, hot water, of course, being as hot as it is, changes quite quickly. In our second test here, we are going to create also a color change with cold water. So we can already see the hot water has changed. Here's our control, and there's our hot water. So I think what is pretty obvious here is that the hot water has changed the system to blue. And you can take a look at your equilibrium reaction and decide if that shift to the reactants or the products. For the cold water, it's typically a little slower for a change, but I think it is possible already to see that there has been a shift away from purple towards the pink spectrum. Okay, and we will leave that in the cold water and take a look at that in a couple seconds here. Our third test is going to be adding something to the system. So we start again with our controlled state here, our equilibrium state, and we are going to add water as a reactant. Now, water here is going to be added at room temperature so that temperature is not also a factor. So only one manipulated variable. And let's observe the change as I add distilled water to the system. And we can see that the color did not dilute and become a lighter purple, but the color did in fact become pink. And we can compare that to our control, and we can see that adding water did in fact turn the solution pink. Our final test is going to be adding a product. As we take table salt, sodium chloride, and we add table salt to our system. Now, by adding table salt into the system, we are adding chloride ions to the system. Now, our cobalt complex was already quite saturated, so I need to agitate this system here in order to help force the chloride ions to dissolve into the system. And as I agitate it, and then bring again the control, it might not be as obvious, but hopefully we can see that this has indeed shifted, and while still purple, it has become more of a blue purple. So if we want to consider the control more of a mauve, this would be considered more of a violet, more along the blue side of the spectrum. Again, how you describe it is up to you, so long as we can see that this in fact has become less pink and more blue. And one more time, we will take a look at the changes. We can see increasing temperature or adding energy has shifted blue. We can see decreasing temperature or removing energy has shifted pink. We can see the addition of water shifted pink, and we can see the addition of salt as chloride ions has shifted blue.